Hello everybody and welcome back. We're going to be doing another compass straight edge construction in our wonderful GeoGebra environment. We're going to be looking at the incircle of a triangle. So let's get ourselves a triangle and we'll make it a purple triangle. So we're going to get ourselves a circle inside this triangle tangent to all three sides. Okay. So when we move it around like this at the end, the circle will stay inside. So what do we need to do for the incenter? Because in order to draw this, we need the incenter. And that gives us the center of the incircle. So you might remember, or maybe you need a little bit of a refresher, we need to get to bisect each of these angles. And where they intersect is going to be our incenter. Okay. So, well, what can we do? Let's bisect some angles. I'm going to draw the full lines just because I don't know where things are going to intersect when I draw these circles. Suppose if I were clever, I could always choose the shorter one, but, you know, why worry about that? So we need to perpendicularly bisect the distance between C and this other point, and that will run straight through A, bisecting the angle at A. Alright, so there's one of our bisectors. Now this is going to get real cluttered real fast, so let's clean up a little bit of this. Okay. Let's bisect another one. CB looks shorter. Yeah, there it is. Get the other point, and now perpendicularly bisect B and this brand new point. We really only need to distinguish one of these because I do know it's going to have to pass through C, but why not create both of these points and show that it does pass through C through mathematics? Alright, so there's another angle bisector. We're doing great. And hide the rest of this work, leaving only our two angle bisectors. Okay. And oh, we need the third one. All right, so we've got that point, this point over here, and need to perpendicularly bisect that invisible length, and that will angle bisect the angle at B. There we go. So we do have our three angle bisectors, and we can see that, yeah, they do all intersect at a common point. Okay, I didn't have anything else left. I'm actually going to get rid of these lines. I might need to add them back in a moment, but I just wanted to show that, yeah, these guys do all intersect at the same point, which I always like seeing. Okay. So let's distinguish that common point, and that's going to be the incenter. Okay. And now, what is it that I need to do? I do most of these constructions from memory, so now I'm trying to remember. If I had a circle in here that was tangent to these points, from the incenter to the point of tangency would be a right angle. So let's drop right angles from this point to the sides A, B, and C. We'll only need one of them because that's enough to determine the radius. The center and a point gives you the radius. So let's create a line through this point parallel to AB, and then we'll get one perpendicular. Okay. So I do need to add in AB back again. That's okay, no worries there. Just shorten this a little bit for the construction, just because I don't want to have to always zoom back out. Never mind, zooming out anyway. Okay. Thought I'd shortened it enough. So first we're going to get a perpendicular line to AB through A. Wow, I really need to zoom out now. So now this is perpendicular at A to AB. So let's get ourselves, we need to construct this circle, and then from this point here, go back to the incenter, and the opposite point of intersection, you get a perpendicular line, or a line perpendicular to the line that we constructed that was perpendicular to AB running through A. So it's perpendicular to a line that's perpendicular to AB, it's got to be parallel to AB. And so now from there we can construct a right angle at the incenter through this parallel line, and that'll intersect AB perpendicularly as well. Okay, so perpendicular bisectors to the rescue. We make it so the incenter is the midpoint, and so when we create the perpendicular bisector of this diameter, it'll have to run through the incenter. Okay, so that one, and what do we need? It needs to run through here. Yep. So up here as well, right above the incenter. I probably should have gotten rid of some of the circles there just to make this a little clearer as to what's going on. In fact, let's do that now, although we're almost done, actually. We just need to keep this one line here. Keep that, keep the incenter. So now this hits AB at a right angle, and that's exactly the point of tangency. So now let's connect up, and what do you know, it fits in quite nicely. We've got ourselves an incenter and an incircle. We can even get rid of these guys, and just as I predicted, we can move this around. Oops, there was another off-screen point hiding from me. Are there any others? Nope, I think we're good. So we'll zoom back in, and we can move this whole thing around, and the circle stays inside. It's an incircle. So I always like moving it around and seeing that it really does work. So we had to create incenter with angle bisectors, and then from that drop a perpendicular to one of the sides. Didn't matter which side. Could have done them all and shown that the circle really does pass through all those points, but you guys probably already knew that. So there we go. Construction of an incircle. I like it. Contrasts nicely with the construction of a circle. And that's about it. So thanks for watching. I'll see you guys for another video another time.